Okay, now we talk about question 6. This is the interesting questions. Okay, so it is saying that a function f is defined by f such that x map to ax plus k and x minus a. Okay, x belongs to R and x is not equals to a. So we can see that this is the hyperbola, okay, with the monotonous function. So we can straight away draw the asymptote. The vertical is x equals to a, okay, and also that the other horizontal one is ax plus k, right? So this is x, right? So it's a as well. How do you do that? Long division. So this is just beside how we solve this problem. I just want to give some background of you that how do we address this thing. So normally you can write it fx equals to a plus k plus a squared divided by x minus a. Notice that this is a constant term, nothing to do with x. So this can be safely done in that manner. Okay, this is just a heads up for you, then how you logically thinking that how to solve this question. It may not be applicable later, but I can see that if let's say this is a, definitely when you exchange x and y, when you do inversing function, it will be recurring. What I mean by recurring, it will be the same. For example, now is y equals to a plus k plus a squared x minus a. So later on when you change x, will it be recurring? You look at this term. This is the green color is derived from here. The blue color derived from here. So you see when we do math, we need to have a foresight. This is x minus a, y minus a, this is x minus a. This is x minus a, this is y minus a. So both are multiplication. So that means that associative law say that a times b equals to b times a. So actually the inverse is the same as the mapping. So it will be a 1-1 function and the inverse is equal to the reflection itself. So you have this in mind, then later on the question will be easier. The first question it asks you to do is that describe fully the sequence of transformation. Oh, this is the killer part. For which to transform from y equals to 1 over x onto the curve y equals to fx. You're not doing the further math syllabus, so there are not so many transformation required here, but again we try to understand that so that means transform from here. First we target your x, not your ex-boyfriend or girlfriend, your x, okay, the x on this equation. So this is y equals to 1 over x. You know that this is minus a, so that means that this curve have to be, initially it was like that, so it have to be shift if a bigger than 0, shift to the right to a. A unit. So this is the first step, shift to the right. Secondly, we know this coefficient is 1, but it gives the coefficients of k plus a square. So k plus a square, that means that it is skew. That means it's expanding. So this, the next step is going to do is that this x minus a is going to times k plus a square. So it's expanding with k plus a squared. That means that when you have amount of x, it will keep on expanding. So now your a is here. So this become bigger. For instance, you have a plus 1 here. No, I mean previously was 1. So now become k plus a. Okay, if x, this is 1 unit here. Okay, so this is expanding. Thirdly, is that you know that your equation y equals to a plus k plus a squared divided by x minus a, so it leaves out, right? So this is the initial one. So the initial one I draw in a blue using this white color to draw. Then now you have shifted, everything is lifted by unit A here. So now your new curve will be in the green, something like that. Your the asymptote change. Last time the asymptote was the asymptote. Now you leave out by a unit. Am I right? You just leave out by a unit. So the whole curve leave out by a unit. Okay, shift out in parallel. I think you can draw it, you can write it down in a very, use a textbook to write it down in a more presentable manner. So this is how we interpret the curve. Okay, now they ask us to find the inverse. And that you look at this green and blue, the inverse actually is itself, because when the inverse is very simple, interchange x and y, you get the same equation. You get the same equation. As I just now mentioned. So the same equation, you get the same equation. So when you get the same equation, means that, okay, if f square x, so they will get same equation. So this is the function. The third question asks you to find this x square x. Since we know that f minus x is equal to fx, f square x is equal to f composite fx. So this f composite fx, isn't that f composite f minus x? Correct? So this f composite f minus xx is equal to x. Correct? So it's x itself. So f square x actually equals to x itself. Okay? Got it? So this is 1 point. So now we look at this the very interesting question. Asks you to find 2 points only lah. Asks you to find 2, 0, 2, 3 and 1 here. How do you go to find that? How are you going to find that? It should actually very simple, very interesting as well. This is 2023. So we know that this is 2023, 2021 is x also, correct? So when 2023 is x, you divide by 2. You reduce by 2, this is 19. So everything you reduce by 2, it become what? 1 plus 2, 0, 18, right? X, right? Correct. So this become fx itself, correct? If fx itself, you bring it 1, it become fx itself. Because whatever even number here will become x. This is what we get ma. But this is a 2023 is a odd number ma. So the fx you sub in 1. So fx1 it become a plus k 1 minus a. Okay, 1 minus a, I don't know why I cannot rub this thing, but this become okay a plus k 1 minus a, so 2 marks. So you get this done already. Thank you.